So hi, you have learned the next greater element, the next smaller element, both uses stack to look forward through array. Now here's the question that combines them both. Largest rectangle in histogram. This is a LeetCode hard problem that has been asked at Google, Amazon and Facebook interviews. The acceptance rates for this problem is 38%. Why? Because most people don't see the connection. But you already know the secret. For every bar in this histogram, we need to know how far left can we extend. That is nothing but finding the next smaller element. And second would be how far right we can extend. This is next smaller on the right. Wait, next smaller? You have learned that in the last lecture, right? This isn't a new problem. This is a combining pattern you already know. Same stack, same order of end time, but now we are solving the hard problem. But wait, finding the next smaller element takes space complexity of order of n time, and finding the previous smaller element will be taking order of n space complexity, right? But is there any approach that can be solved without taking any space complexity of an array? Let's find out. So let's break down the most elegant histogram algorithm you will ever see. So over here we have an array. Now each cell basically represents the height of the block. Now if I convert this into a histogram, it will be looking like this. Now over here, basically we need to find the area of a rectangle. And we know that the area of a rectangle is nothing but length into breadth, right? But over here, the length will be nothing but height and the breadth is nothing but the width. So talking about this talking about this rectangle, the height is 4 and the width is 3. So 12 will be the area of this rectangle. So basically we need to find the area of the rectangle and we need to return the largest area. Okay. Now giving some of the example of the rectangle. So over here, you can see that in the first place, I gave you this example in which the height is 4 and the width is 3. So 12 is the area. Now the next rectangle will be looking like this. So over here, the width is 3 and the height is also 3. So the 9 is the area. Now previously it was 12, now it is 9. So the max area that I found till this point is 12. Now this is also considered to be the rectangle in which the height is 2 and the width is 5. Okay, so the area of this is 10, but it is not beating 12, so I'll not include this. Now this is also considered to be a rectangle in which the height is 1 and the width is 10. Okay, again the area is 10, which is not beating 12. Now one last thing, this is also considered to be a rectangle in which the width is 1 and the height is 6. Okay, so basically we need to find all the rectangles and we need to return the maximum area. So let's now see that how we can find this. Now here is the another histogram. Now since I need to find the area of a rectangle, okay, so basically if I want to include this, okay, so the height of this rectangle will be always 3, right? But now my point is that what will be the width? So basically I need to traverse it on the left as well as I need to traverse it on the right. Okay, now if I start traversing, I can include this bar, I can include also this bar, but can I include this bar? The answer would be no, right? Because over here the height of this bar is 2, not more than 3. Okay, now similarly if I'm going on the right hand side, I can include this bar, I can also include this bar, but can I include this bar? The answer would be no, because the height of this bar is lesser than 3. So basically I need to find out the boundaries. Okay, and how we can find out? By traversing on the left as well as on the right. And if I found any element which is smaller than this block or this height, okay, I need to stop it over there. Now since I'm going on the left hand side, so I will be having P1 as the boundary 1, and for the right this will be the P2 as a boundary 2. Now see guys, for finding the number of element between this P1 and P2, the formula is pretty simple, which is nothing but P2 minus P1 plus 1. Okay, so with this formula I can able to find the number of element inside this, but we are not including this nor this. Okay, so I need to place this P1 at P1 plus 1 and P2 at P1 minus 1. Okay, so if I rectify this, P2 should be P2 minus 1 and P1 should be P1 plus 1. Okay, now if I calculate this, the answer would be P2 minus P1 minus 1. So this is the formula for having the width. Basically, I know the height, which is 3, and then width is this. Okay, now if I want to find the width, the value of P2 is 7 and the value of P1 is 1 minus 1. So the width will be 5. So here you can see that the height is 3 and the width is 5. Okay, now we need to do this for each and every block. Basically, we need to traverse for the left, finding that boundary. Similarly, we need to traverse it on the right and finding that boundary. And after getting the boundary, I need to calculate the width. I do know the height, which is nothing but the current element. So height of I into width, which is nothing but this. Okay, and that will be the area. And once the area that you got is maximum than the previous one, then you need to update this. Okay, but basically I will be not going in depth for having the pseudocode. It is pretty simple, but if you think that it is not simple, then give it a try. Now, talking about the time complexity of this approach, see, for every element we need to traverse it on the right, so it will take n time. Also, we need to traverse it on the left as well, so it is going to take n time. So this is 2n. Now we need to do this for each and every value. Okay, so into n. So the time complexity of this, it will be order of n square. And since we are not taking any extra space, so the space complexity will be 1. So this is the code for performance of this approach. Now, as usual, the time complexity is too high, so we need to optimize this. Now the approach 2. In the first approach, what basically we are doing, we are calculating the smaller element on the left as well as on the right. Now the thing is that since we are finding the smaller element on the right, okay, basically we have solved this kind of a problem. This is nothing but finding the next smaller element. So can I take that method and apply it over here? Absolutely yes. So if I try to find the next smaller element for each and every value, similarly this previous smallest element for each and every value, and store it in an array, then I can simply use that values for each and every elements over here. Okay, so the approach 2 will be looking like this. So I will be finding the next smaller element for each and every value, store it in the right array. Similarly, I will be finding the previous smallest element for each and every element and store it in the left array. Okay, now basically I have told you that how to find the next smaller element. Okay, so if you want, you can watch my previous lecture. In that I have shown you in detail, but over here I will be showing you that how to find the previous smallest element using stack. Okay, so here I have created a stack. Now over here I will be traversing from left towards right. Okay, so because if I want to stand over here, I will be knowing that which is my previous smaller element, which is nothing but 4, and this element will be basically stored inside the stack. Okay, so for this element, the previous smallest element is 4. Now let's start. Right now I'm standing over here and I do see that the stack is empty. So for this, the previous smallest element will be simply -1. Okay, for each and every element, if I don't have the previous or next smallest element, the answer would be -1. Okay, but I will be going to change a little, whether it is -4 or something else. I'll tell you in a bit. Now I need to store that value inside the stack. But see guys, over here I will be finding the width. Okay, so I should be knowing the index, not the value. So instead of storing the value, I will be storing the index now. So 0 is stored and the value of this is 6. Okay, only for our reference I am writing it over here. If I have 2, okay, for these elements, can 6 be the answer? The answer is absolutely not. Okay, 6 can never be the answer if 2 is in the middle, because 2 is smaller than 6. So for this I will be simply deleting this 6. Okay, and again the stack is empty, so I will have -1 for this, and I'll store the index of 2, which is 1. Now I'm standing at index 2. I do know the smaller element for 5, which is 2, so I'll have 1. and I'll store index of 5, which is 2. Now I'm standing at index 3. Over here, I do see that if 4 is in the middle, 5 can never be the answer, right? So I need to delete, or I need to pop this 5. Okay. Now I'm not able to delete 2. Why? Because 2 is smaller than 4. So the answer for this 4 is 1. Now I need to store the 4 as well. So 3, and the value present at index 3 is 4. Now for index 4, in which the value is 5. So for this value 5, 3 will be our answer, right? The previous smallest element is 4. And I need to store 4. Over here, the value is 5. Now see, now if the value is 1, can 5 be the answer? No. Can 4 be the answer? No. For 2 can be the answer? No. So I basically need to pop each and every element, since 1 is smaller than all of them. And now the stack is empty. So the answer for this is -1. And I need to push index 5. Over here, the value is 1. Now for index 7, the value is 6. 5 is the answer. And I need to push it. Now elements on the right hand side, if the value 3 is there, 6 can never be the answer. So I need to pop this 6. Okay. Now for 3, the answer will be 5, because the previous smallest element is 1. And I need to push 7 with the value 3. Now for index 8, 4 is the element, and the previous smallest element is 3, which is present at index 7. So I'll write 7 over here, and I need to push index 8 with the value 4. Now see, if I'm standing at index 9, over here the value is 2. Value 4 can never be the answer. Value 3 can also never be the answer, right? So I am going to pop these 2 values. Okay, and over here the value 1 is present, which is present at index 5. So I'll write 5 over here, and I'm going to push 9, and the value is 2. So basically I want these answers, okay, not this. Only for our reference I have written over here. So this is nothing but the left array that basically represent the previous smaller element. Okay, now if you have watched my previous lecture, I have shown you how to find the next smaller element, which will be next smaller element, and that will be stored in a right array. Okay, I'll create the right array. So it will be looking like this. So over here I have created the right array in which I have stored the indexes, okay, of that particular element. Now see, for element 1, there is no smaller element on the right hand side. Same goes for 2 as well, okay, hence I have written -1 and -1. But see guys, since I need to find the width, okay, for this element 1, okay, if I'm going on the right hand side, the boundary would be last index, right? The boundary would be last index, not -1. So due to that reason, I need to write 10. That means nothing. That is nothing but the length of an array. Okay, I hope you got this. That's why I have written 10 instead of -1. Now, since I got left array as well as right array, now I need to find the width. The formula is super simple. P2 minus P1 minus 1. So this is P2, this is P1. So let me write it as well. Okay, after finding the width, now we need to find the area. So let me bring the histogram. Okay, and I'll write the left array and the right array. So now I need to find the width. So the answer will be 1 minus of -1 -1. So answer will be 1. 5 minus of -1 -1. The answer would be 5. 3 minus 1 -1. The answer would be 1. 5 minus 1 -1. The answer would be 3. 5 minus 3 -1. The answer would be 1. 10 minus of -1 -1. The answer would be 10. 7 minus 5 -1. The answer would be 1. 9 minus 5 -1. The answer would be 3. Now 9 minus 7 -1. The answer would be 1. And 10 minus 5 minus 1, the answer would be 4. Okay, now the area will be simply the height, that means the current value, which is 6, into width. So it will be looking like this: 6, 10, 1 into 5, the answer is 5, 3 into, here the value is 4, so 12, 1 into 5, the answer is 5, 10 into 1, the answer is 10, 1 into, here the height is 6, so 6, 3 into the height is 3, so answer will be 9, 1 into, here the height is 4, so answer would be 4, and 4, here the height is 2, so answer would be 8. So among this, 12 is the maximum, so we need to return this. Okay, so I believe you got this. Now let's talk about the pseudocode. Now first I'll find the previous smaller element, in which I will be first creating the array. So left array, the size will be n. Now for I equals to 0, it will be gone till n. Now over here, what I need to do, while stack.size, if it is greater than 0, and array of stack.peak. Okay, since we are storing the indexes, hence I have written inside the array. If it is greater than current height. Okay, since if that's the case, then I need to pop it. So st stack.pop. Okay, now I need to check if stack dot is empty. If it is empty, then basically I need to have left array of I is equals to -1, right? Else, if the stack is not empty, then left array of I is equals to stack.peak. And as you know, after every operation, we need to store that value or store that index into the stack. So stack.push I. Okay, we are going to store the indexes, not the values, hence I. So this is for the left array. Now similarly, without doing any change, I will be creating the right array. And the logic is pretty simple. That means pretty same. The only thing is that I need to come from right. So instead of coming from 0 to n, I will be coming from n minus 1 to 0. Okay, and all the logic will be same. Okay, only I need to change the left towards right. Okay, these two for loops are usually created for finding the left array and right array, that is nothing but previous smaller element and next smaller element. Now I need to have simply one for loop in which I will be 0, I is less than n, I plus plus. Now over here, P1 will be left array of I and P2 will be right array of I. Now I need to find the width. So width will be nothing but P2 minus P1 minus 1. Okay. Now the area will be area of I into width. So max array is equals to max of area comma max array. So over here it is getting updated, and that's it. We are done for this. So we need to return max array at last. So you can initialize the max array to 0. Okay, and over here you can use it. Now talking about the code performance, since here I have run one for loop, it will be n time. Here it is also n time, and here it is also n time. So basically the time complexity for this is order of n. But see, for this space complexity, I have created two arrays for the left array, right array, as well as stack. Okay, so it is going to be 3n, but approximately it is n only. Okay, now there is also one way in which, without creating the arrays, the left array and right array, we can still find the answer.